Hello everyone, my name is Ayumi Manawadu and I'm a PhD candidate in civil engineering at Washington State University. Today I'm going to briefly discuss about our ongoing research efforts on test methods and bond performance characterization of shotcrete-concrete interfaces. This project is funded by Tri-Lee and WashDOT, and my advisors are Dr. Haifang Wen and Dr. Pijong Chao. To discuss a little bit about the background of the study, shotcrete is a type of concrete that is sprayed at a very high velocity onto a receiving surface. Because of this high impact velocity, shotcrete doesn't require vibrations or formwork and is very popular in overhead and vertical construction work such as tunnels and embankments. It is also a very popular repair material to repair concrete, damaged or old concrete surfaces, but in such instances it is very important that the shotcrete overlay bonds very well with the concrete substrate to avoid any debonding or peeling off from the surface. If that happens, it may reduce the life expectancy of the whole structure. Therefore, it is important to evaluate the bond strength and durability of such repair rehabilitation techniques. However, the most common test method available to analyze or evaluate the shotcrete concrete bond is the pull-off test as indicated in the figure. This pull-off test has a major drawback because it may or may not give you the strength of the bond, because due to the uniform cylindrical geometry of this pull-off test, when it is subjected to a tensile load, it may break from the substrate or from the overlay or at the interface bond. Therefore, it would rather give you a strength parameter idea about the strength of the interfacial zone than the specific interface bond. In contrast, the shear-off test does make sure that the bond is separated, the specimen is separated at the bond itself. However, to achieve this, it applies a huge cutting load at the interface bond, which may not depict the real life scenario. So the results might be biased. Therefore, we are proposing a fracture mechanics based butterfly doubly wedged specimen to analyze this strength, the durability of this concrete shotcrete interface bond. So, in contrast to uniform cylindrical specimens, this specimen has the narrowest cross-section at the interface. Therefore, there are more stress concentrations at the interface bond. To design this specimen, we conducted a finite element analysis using abacus, where we changed the wedge angle theta, and we subjected the specimen for direct shear, direct tensile, mode 1 and mode 2 loads. And depending on all those results and after considering the ease of construction, we decided to go ahead with 45-degree wedge angles for the butterfly specimen. In the experimental aspect of this study, we cast the concrete substrate of 75 butterfly specimens in the WSU concrete lab, cured it in a lime bath for 28 days, and took it to a specialized nozzleman to cast the shotcrete layer. And these specimens will be subjected to freezing and thawing conditional cycles, up to 300 cycles at 60 cycle intervals. At the same time, we will test cylindrical specimens as a benchmark. However, to analyze these specimens, I must mention I will not explain this whole model. However, I must mention that we are using a nonlinear fracture mechanics model because fracture behavior of this shotcrete concrete interface bond is quasi-brittle. Therefore, we cannot use linear elastic fracture mechanics concept. Hence, we will use fracture energy as our key parameter in this analysis. I hope this new testing method will be a better solution to measure the durability of concrete shotcrete interface bonds. Thank you.